All right, so now for example number 3, they give us a bunch of values, all right? So they say when x equals a number, and they give us 2 functions. So we're going to look and study, and this is what different exponential functions look like if we plot them, right? 0, 1, and 2. So the first function they give us is g of x, and they tell us that it's 4/9, and then it's 4/3, and then the next value is 4, and then 12, and then 36. So now the question that I have to ask you guys, is there a pattern there? We see that when we change our x value, we're just adding 1. So we're just adding 1. Our change in x is just adding 1. So for every value of x that we add 1, what happens to our y values? Multiplies by something? What's the something? 3. Yeah, it's very clear here that we see that we're multiplying by 3, and to get from here to here, we're multiplying by 3. And so what we want to do is just verify and make sure that that works for every one of those. Okay? So now, if I take 4/3 and I multiply it by 3, if I take 4/9 and I multiply it by 3, would it work? And the answer is yes. If I take 4/3 and multiply it by 3, will it work? The answer is yes. And if you can't, think of it like this. If I say 4/9 times 3/1, well, that becomes 12/9, which reduces down to 4/3, right? Does that make sense? Okay. And so now, if I were to try and guess what this would be, what is the base? Well, the base is whatever we're multiplying this by. So because we're multiplying by 3 every time, that's the base of the function. So remember that this function is written in the term, it's written like this: y equals a times b raised to the x. Well, we figured out what b is. What do we have left to do? Find a. Now a, if you have the table of values, a is always the function evaluated at 0. You know why? Well, remember that this represents the point 0, 4, and those are the x, y values. So if I were to put 4 here is equal to a times 3 raised to the 0, right? Well, what's 3 times 0, or 3 raised to the 0? 1. What's the a value? 4. So this particular function, g of x, is equal to 4 times 3 raised to the x. Does that make sense, how I did that? I'll show you how to verify that on the calculator in a second. Okay? Let's do one more function. Let's do another function. We'll call this function h of x. And so they give us the values for this, and now this time I have 128, 32, 8, 2, and then 1/2. Now, for exponentials, what we're looking for is a base that we multiply by. But if you notice, 132 drops down, or I'm sorry, 128 drops down to 32. Huh? 1/4. What I was hoping that somebody might say, but you guys are too smart for this, I was hoping somebody in here would say, well, you divide it by 4 every time. which is the same as multiplying by 1/4, right? But you guys are way too smart for that. You figured it out right away that your base is going to be 1/4 because we multiply by 1/4 every time, right? Every time we multiply by 1/4, and that gives us the next number. Yes?
To find our base with these, do you have to always multiply by something? Or
Yeah, if it's an exponential function, you're always multiplying by the same number.
Okay, so you can't divide by something if you want to divide.
Now, yeah, you divide, if you're dividing by a number, then you can multiply by the reciprocal,
Okay.
always. And that's what we did here, right? So, all right, now let's see if we can find that pattern on our calculators. What Mr. Adams is going to do is I'm going to come in here, and I'm going to change this to -2, 1, 0, oops, forgot to do the 0, 1, and 2, and we'll clear that last one. No, I want to clear it. It's not cooperating with me today. Oh well. Well, let's just clear the whole list. We'll start over. So, all right, now we're starting from scratch. So I've got -2, -1, 0, 1, and 2. Oops, did them both in one thing there. 1 and 2. And then I'm going to put the corresponding values, which are 128, 32, 8, 2, and 1/2. And then your calculator will convert that to a decimal, which is 0.5. So now, if I come in here, I got to clear some things out. Make sure that my plot is turned on. We'll turn that on. And then lastly, I'm going to set it up to graph stats, which is 9. Those are the points for h of x. Now, before I let the calculator do its work and tell me what the function is, let's try to do this by hand. What does, if you had to guess, what is h of x? Well, we know that the base is equal to 1/4. How do I figure out what a is? I heard it. Somebody said it real quiet. Do I say it louder? No? Where x equals 0. So I'm looking, it's right there, it's 8. So a is 8. So that looks a little cluttered. Let's go to another slide. So what I'm really looking for is I'm saying that h of x is equal to a times b raised to the x. We said that b was the number that we continued to multiply by, which was 1/4. And then we said a that occurs when b is raised to the 0. And in that particular set of numbers, we said it was 8. So what we're saying is that h of x is equal to 8 times 1/4 raised to the x. Now, could I change that and make that 2 raised to the x? Right, because 8 times 1/4 is 2. Can I do that? No, you can't. No, you can't. Okay? Sorry, Mr. Adams tricked you. It's a Monday morning. Remember, if we follow order of operations, what do we do first? Parentheses. But yeah, exponents comes before multiplication. So I would have to apply the stuff in red first before I multiplied it by 8. That's why we can't multiply 1/4 times 8 and then raise it to a power, because that's not how math works. Okay? So, that's what we should get. Let's see what the calculator tells us. So now to calculate the regression of this, it's just like you would do a linear regression. I'm going to go to stat. Then I'm going to come over here, and I'm going to come down, but it's a exponential function, not a power function. So I'm going to go until I see where it says exponential regression. Right? So I'm going to hit enter. Do I want to store it? Yeah? Yeah, well, let's just calculate it. Were we correct? Yep. Okay, good. That's it.